Hello and welcome to Breaking Down Cloud Security with MentorSource. My name is Scott Hogue. I'm Chief Technology Officer for GTRI in Denver, Colorado. I've been working with network infrastructure, security, and now cloud-based systems for several years now, and focused on the security of that infrastructure and operating securely in a cloud environment. Today I'll be sharing with you the common ideas around how to proactively plan to secure a cloud infrastructure, as well as if you're already operating in a cloud infrastructure, the things you need to double check that you're operating in that environment securely. The agenda for today, we'll go through a quick review and level set of the characteristics of cloud services and the security-related aspects to those characteristics of cloud services. We'll talk about what are the things we need to consider when using cloud service provider services and the things we have to consider to make sure we're protecting our data, we're operating in that environment with the proper controls. And we'll have examples of several popular cloud service providers, and we'll talk about, what are their standards, guidelines for operating in their environments, and we'll see how their security models are different. We will see what the customer responsibilities are for operating in those cloud environments, as well as understand what the service provider does. We'll talk about software container security and how the use of software containers in a cloud infrastructure changes the way we think about security, or what new opportunities that may give us to greater secure our applications. We'll talk about examples of some cloud security controls and look at examples of other components that can be added and layered on top of an infrastructure to make it even more secure and give us more visibility and control of our data and applications that we're running there. We'll talk about other security services in the cloud. Can the cloud actually provide us some security benefits compared to traditional perimeter-based internet defense strategies? And we'll talk about some cloud security certifications, some areas and places to look for to learn more about cloud security and the body of knowledge in the domain, and what are those certifications to look for. So as we go through a brief overview of cloud computing, we kind of need to review the characteristics of cloud computing and consider how this changes how we may secure using an environment like that. Cloud is a type of network-based computing model where organizations consume a pool of resources that the cloud provider has and offers. You can use their data, their compute, their storage resources, and you consume from a very large pool of these resources. The cloud, as its name implies, has abstracted the concepts of geography, physicality, ownership. All of these resources are virtualized among many people who are consuming the cloud resources. This is a shared resource pool, so it transcends the responsibility of any single organization. But then you also get greater economies of scale because you're renting that infrastructure rather than having it be physically dedicated. So just from this high-level definition of cloud, we can start to think about what are the security implications. Obviously, data privacy and confidentiality is a concern because now we're sharing something, and we may not want to share this particular data. So understanding the classification, marking our data appropriately is something we need to consider. And also, if it's shared and we're renting something, can we guarantee that it's going to be there when we need to, when our businesses rely upon those resources? The availability of those cloud resources is important. We need to be able to rely upon them as much as we do our current on-premises data center infrastructure systems. And also, because the geographical dissolving and the removal and virtualization of where these things are stored, where the data is stored, the legal jurisdiction for the geography of distributed resources becomes a concern. So you can see, even just from the high-level view of cloud computing services, it changes the way we think about computing. So if we think about this picture where we have two, highly conceptualized virtual servers here, or server infrastructures, We have now virtual computers and instances of computers running as virtual machines, if you will, on some virtualized network infrastructure that may include data center networking, firewalling, load balancing, other services. It's virtualized inside of these hosts. And these are massive scale data centers that are servicing many tenants that are hosting data and storage and compute and applications in this infrastructure. The cloud connects all of this, and your data may be moving across or within. So it's difficult to physically determine, where your data is and point to a server that might be running your particular application. And so you can see that with this introduction of network function virtualization, the security of the hypervisor, the virtual environment, changes how we design a network to be secure. There really isn't a choke point. We have a very diverse set of components here that we have to think about securing. And so it changes our design. The 5 characteristics of cloud are on-demand self-service. So we get to provision our resources as we see fit. We have broad network access, so we have reachability from the internet and many networks. There's resource pooling, so the service provider has pooled a large volume of servers and storage systems that we can essentially have an inexhaustible supply, and we just rent what we need. And we have rapid elasticity. We can rent more or less on a moment's notice based on our mission, our application, our needs, and the nature of our business. We also have measured service. We only pay for what we use, so we're renting a type of service here. So each of these characteristics has a corresponding security implication to it. We have on-demand self-service. Well, could any user in our organization just start to consume resources without checking with someone first? Broad network access. How do we secure a system that's so geographically diverse? Where we have resource pooling, and there's an e-discovery legal matter, and the service provider gets a legal request to pull apart those systems for some legal investigation. Where is our data, and how can we show that that was not e-discovered? We have rapid elasticity. Well, maybe we could overconsume and now our bill is more than what we'd expect or something like that. So these are concerns that someone may inadvertently attack our systems and drive up our costs. So there are 4 different deployment models for cloud: a public cloud, which is really open to the general public; a private cloud, which is really for our own use; a community cloud, which is for use by a consortium or group of organizations that have gotten together to collaborate; or a hybrid, a combination of any of those previous 3 models. So if it's a public cloud, then it's really our data could be exposed to a broader array of people than maybe what we would want it to be. If it's a private application and it really has security implications and data confidentiality, maybe we want to operate it in a private cloud. But if we're sharing data in a community cloud, we want to make sure that those people, those organizations that are a member of that community are vetted before they join. So even these 4 deployment models of cloud have security implications as well. And the 3 cloud services models, infrastructure as a service, platform as a service, and software as a service, also have security implications. If we think of this model, and Albert Barron put this together, if we think of these 3 models as pizza as a service, our current traditional on-premise data centers are really the made-at-home pizza model. We provide the dining table, the kitchen, the cooking resources. We make the dough, we provide the ingredients, and we do the cooking process ourselves. That's very much what we do today in our current on-premises data center infrastructures. That's a very traditional model of building it all ourselves. We build our own storage, compute, servers, network, infrastructure, security, and we can control all aspects of this. We know exactly what we're going to make. We can physically secure it, we can lock it up, and we can control access to it. As we start to move right on this chart, now the cloud service provider bears the responsibilities for the lower level infrastructure, Now the customer retains responsibility for securing the operating system and their applications on top of that. In platform as a service, the service providers providing, a little more components, and software as a service, the service providers providing even more, and we're just basically dining out. We go get the pizza and we consume it at their restaurant. So, but we dictate, the type of pizza we want to order, but it's up to the service provider to provide that pizza to us, and we pay a premium for that. So that's a little bit more like software as a service. So these three models, and which one is right for us, and how much responsibility does the service provider have compared to the responsibility we have for security in each of these components varies. And they can be a subset of each other. They can be layered on top of each other. So a software as a service could be provided on a platform as a service or an infrastructure as a service provider infrastructure. So there could be other third parties, depending on the type of software as a service we may be consuming. There may be other groups, and the infrastructure that this may be running on may be run by another cloud service provider that is contracted. And you can see that there would be flow down responsibilities for security in this type of a case if you were using a platform or a system like this. In the federal government, we can look to the NIST guidelines for how to plan for and secure cloud infrastructure. The NIST Cloud Computing Public Security Working Group provides examples and does research on cloud services and how the federal government should consume these resources. Several key NIST special publications, 500-292, the Cloud Reference Architecture, kind of provides some of that background information that we just covered on the 543 model of cloud. The 500-293 is the technology roadmap. There's 3 of those volumes to that technology roadmap. NIST Cloud Computing Security Reference Architecture gives us guidelines and advice on what we need to do from a security standpoint based on the type of model of security services that we're using. 144, 145, and 146 in the 800 series give us the security-specific guidelines around public cloud infrastructure and how to use that and maintain the privacy of our data. The 800-145 gives us a little more definitions of cloud computing, as we just reviewed, and 146 goes into specific recommendations, also covering cloud security-specific ideas. So we can look to these NIST guidelines on how we should operate in the cloud securely. So thinking about cloud security, a breach to a cloud service provider's infrastructure can lead to what's known as hyperjacking, where many customers' data is exposed. And there have been examples of these types of breaches in the past. There was a Google failure that exposed data. 150,000 Gmail accounts were leaked. There was a Codespaces. The business actually ended up going out of business because their AWS infrastructure was hacked to the point that their systems were turned off and their data was lost. So a complete business going out of business because all their developer, source code repositories, project management services, everything got shut down. Google Drive breach that was a hyperlink vulnerability that leaked information. Apple iCloud exposure made the news. Dropbox security breach compromised, many passwords. People had to change their passwords. Worcester Polytechnic Institute claimed there were VM virtual machine instance breakout possibilities in AWS even. So it's important to keep up on, the latest activity and the latest research that's being done on cloud security. But this can give us an example that these systems are vulnerable. We have to, secure our data when we're operating in a cloud service provider's infrastructure. But we also need to check to make sure that these cloud service providers are treating our data confidentiality and that they're following best practices. So depending on the model of cloud service that we've contracted to use, varies our responsibility to protect. So in an infrastructure as a service, we bear more responsibility to provide configuration of that infrastructure, of those compute resources. We have more responsibility in the storage of the data, and therefore we have more responsibility for the security when we operate in an infrastructure as a service style cloud platform. In a platform as a service, the service provider provides a little bit more of the foundational responsibility for security. So you see the provider's responsibility has grown a bit into the infrastructure, and that's their responsibility. But we're still ultimately responsible for our data and how we're using that platform and how we're storing our data. As software as a service, the provider bears more responsibility. This is the example like in pizza as a service. We're just going to a restaurant to order pizza. We just care about the security of the pizza that we've ordered. How that pizza was made is the responsibility of the provider. And so the provider bears more responsibility to secure the infrastructure, secure the compute, secure the data, secure that application. We're just simply using that software as part of our contractual obligation. So in these shared security models, depending on which platform you've used and which model you've used, it changes your responsibility as a cloud customer with regards to security. So cloud compliance and assurance is an issue. We need to verify that our cloud service providers are meeting certain guidelines and industry best practices with regards to security. Many service providers and data center companies and co-location providers adhere and have their infrastructure checked against the American Institute for Certified Public Accountants audit reports to attest that their services are available and highly redundant. They have these accreditations and certifications performed, and these audit reports, these SOC 1, SOC 2, and SOC 3 type audit reports attest to the service provider's foundational infrastructure, the building, the physical security, the reliability of the power, the cooling, the physical space, the physical infrastructure that the provider is providing that then stores and houses the computers, the data storage equipment. And so this is very much the underlying physical infrastructure of that provider. That's what these SOC 1, 2, and 3 reports provide. And so you want to ask your provider, do you have these? Do you have enough generator capacity, enough diesel fuel in the generator capacity to sustain an outage? Because you're paying for a service, you want to make sure that it's highly reliable. And by looking for a service provider that has these audit reports, gives you assurances that they've taken that into account and you can rely on it. That in the confidentiality, integrity, and availability, three-component model that we tend to think of as security practitioners, the availability is taken care of. So these would be attestations and assurances that the service provider would be highly available. The International Standards Organization, ISO 27001, many service providers operate with this and use this as their ISSM, and so we can validate that if they're following these security best practices for creation of ISO standard, if they're following those, if they've been audited against this standard, that they're treating their own data appropriately and they're protecting your data as a cloud service customer. The Cloud Security Alliance has their CSA STAR accreditation as well. The U.S. Health Insurance Portability Act, HIPAA, HITECH, also certifications to look for that a service provider may have. Also, a cloud service provider may be PCI, Payment Card Industry certified. So if we are going to be performing credit card transactions or storing any credit card data in their infrastructure, we want to make sure that their infrastructure is helping us meet those guidelines. And if we're doing anything with the Motion Picture Association of America, we want to make sure that the security of that film and that integrity of the processing or developing on a motion picture is followed, we would look for that as well. So many service providers have many of these. Some have just a few. We would want to make sure that the cloud service provider had the assurances and certifications and accreditations that we need to. We can look at their website. Their website often has many of these publicly available. And we would, if we had additional requirements, we could ask the cloud service provider if they have additional data they can share with us, and they can share with you these audit reports on request. But consider the cloud service provider's position. They often have to respond to many different security questions and assessments they get from each customer. If each customer gives them a separate questionnaire to fill out, it really bogs down their process, and they may not be very responsive to getting your specialized query processed. But if you look at your website, and if you are basing your standards off of these assurances and certifications, then they'll map up, and it'll make it easy for the cloud service provider to tell you if they're meeting these guidelines or not. So here, for example, if we go to Amazon Web Services compliance page, aws.amazon.com/compliance, we can see the different certifications and attestations they have about their security. So we can see that they have PCI, HIPAA, their SOC certifications. We can see, a variety of their certifications and attestations. We can see that they're FedRAMP. We can see FIPS. We can see their ISO 27001. We can see their SOC certifications. We can see their ITAR standards and the laws, regulations, and privacy that they follow. We can see other alignments they have to other frameworks like the Cloud Security Alliance, for example. So there are great resources on these cloud service providers' websites that we can look to. For example, if we look at Microsoft's Trust Center, we can see that for their Azure services, they have many of the popular cloud security certifications as well. Cloud Security Alliance, FedRAMP, FISMA, FIPS, HIPAA, HITECH, ISO, their SOC 1, 2, and 3. By going to these organizations' websites, we can see that they may meet our requirements for cloud security, that they've taken it upon themselves to certify their infrastructure and their applications and their platforms per these best practices. And we get some assurances from this that operating in this particular cloud service will give us the necessary settings we need to operate in their environments securely. I mentioned the AICPA and the SOC standards. These are required for many organizations that have to meet Sarbanes-Oxley or SOX compliance. If they have systems that their business financials are relying upon, those systems are then in scope for their SOX compliance. And if they are operating their business financial systems in a cloud environment, and that cloud environment goes offline, they cannot process any payments or receive any payments. And so it's a financial risk for a business that is publicly traded. And so as part of these Sarbanes-Oxley requirements, that organization operating in the cloud must flow that down and make sure they're using a service provider that meets these availability requirements to have those systems up and operational all the time. And so these statements on standards for attestation engagements, SSAE 16, replace the previous SAS 70 requirements. These are the attestations that infrastructure is available and ready, and you can rely upon it to run your business financial applications. So look for organizations that have their SOC 1, SOC 2, SOC 3 accreditations if that's what you require. We mentioned the ISO IEC cloud security standards. There's 27001 is the Information Security Management System guidelines from ISO. ISO also has two specific security standards for operating in the cloud: a cloud computing overview and vocabulary, what are the concepts and ideas around cloud security, and then a reference architecture that gives you models in a little more detail. So these are also standards. If your organization follows ISO guidelines, these may be ones that you would want to follow as well. And then for U.S. federal organizations, they have specific requirements for how they consume cloud services. The DIACAP and FISMA accreditations you're probably familiar with. Civilian or DoD organizations may have to meet these in terms of privacy of their data and how they secure their infrastructure. And there are some FISMA compliance changes that are coming to the federal government in 2016. Cloud providers must also meet these requirements, and if we're operating federal workloads in a cloud environment, we want to make sure that the cloud provider is meeting these. Also, cloud providers may be required to meet international traffic and arms regulations compliance, and also federal organizations may have requirements where their data cannot leave the boundaries of the United States. And as we mentioned before, characteristics of the cloud is that the geography and the concept of geography and the physicality and location of that data may be diverse and disperse. And so we would want to work with a cloud service provider that could assure us that all of our data is held within the geographical boundary of the United States. Federal governments also have to meet FIPS 140-2 for securing and using encryption and securing of the keys. And so if we encrypt data in a cloud provider, if we're encrypting data in transit between our organization and the cloud provider, we want to make sure that those keys that we rely upon for the confidentiality of the encryption are also protected per the FIPS standards. And the Federal Risk and Authorization Management Program, FedRAMP as it's called, is the method with which service providers are assessed and required to meet for many federal organizations to even choose that provider. So you want to make sure you're looking for service providers that have met FedRAMP accreditation. The process is sometimes a lengthy one. The service provider needs to go through this process to be accredited. The OMB requires that FedRAMP accredited cloud service providers who are operating in low or moderate level security classification categories go through and use their systems based on FISMA and the NIST 853 standards. The FedRAMP established this Joint Authorization Board, the JAB, to approve cloud service providers and monitor the process of certifying them. The JAB defines the standards with which assessors, third-party assessment organizations, or 3PAOs, are using to assess the cloud providers. Those assessors, those auditors, if you will go in and audit the cloud service provider to make sure they're following all of these security best practices. Companies like Coalfire, Kratos, Veris are auditors that would audit the cloud service providers. The auditors then would validate if they meet all of the FedRAMP standards. The report goes back to the JAB, and the JAB, after review of the security assessment package, would then deem that service provider as FedRAMP certified. So there's a process and checks and balances of auditors, and the JAB, manages this process. So understanding the process with which the service providers go through is important. Understanding the components that they're being checked against is valuable, but look for this FedRAMP icon on their website and ask them for their report to validate that if you're going to choose this cloud provider, they're operating securely for federal organizations. The Cloud Security Alliance is a not-for-profit organization that really promotes best practices of using cloud services and promotes the best practices with which service providers and customers of those cloud service providers use and think about and organize themselves to meet security in the cloud. This group really wants to see that cloud services are being used and that security is not an inhibitor for the industry to move forward with cloud. The group was formed in late 2008 and now has quite a few members. This nonprofit group has created many guidance, documents, training, valuable resources on their website, cloudsecurityalliance.org, for free public consumption, One of the things they've created is a security guidance for critical areas of focus in cloud computing. The current version is 3.0, and that really spells out the domains and all of the areas that you focus on. Everything from, securing data, how do we, store data in the cloud, how do we treat applications, how do we assess the service providers, how do we operate applications securely in the cloud. A very large document, freely available on their website, gives you lots of great resources and things to think about as you plan for or assess the way you're using cloud computing services. The CSA also has their STAR, the Security, Trust, and Assurance Registry, with which a service provider can go and validate that they are meeting these guidelines as well. The level 1 is a basic self-assessment. Level 2 can be a certification or an attestation by a CSA STAR certified auditor, and they can go through that assessment as well and publish their results. And then the level 3 is really continuous monitoring and management and observation and checking, continuously validating that they meet those requirements. So if you're looking for a service provider that has CSA STAR, you look for their logo on the website to see that they meet these guidelines and see what level they're operating at. The Cloud Security Alliance also, has historically published many articles on what are the current levels of threats. They started many years ago saying that there were just kind of 3 threats against cloud systems: insecure interfaces and application program interfaces, data loss and leakage, and hardware failures. So kind of availability, confidentiality, integrity, those concepts were how they started out. They realized that after doing some surveys that those accounted for 29%, 25%, and 10% of all cloud outages, respectively. So fewer hardware failures, but more failures along the lines of, insecure use of API configuration control of those cloud services and data loss. In March of 2010, the CSA then published their 7 security threats. You could see them here. So they came up with a list of 7 items that were the common things that organizations that affected not only cloud service providers, but also the customers of those providers. And so, abuse of nefarious use of cloud computing, either by, malicious insiders or attackers, insecure interfaces and APIs, again, carried over from the previous computing threats that they had published. Malicious insiders, again, someone doing something bad who is an employee of the cloud customer or the cloud provider. Shared technology issues, so that concept of multi-tenancy and where is my data. If the cloud service provider has a breach, it can expose many organizations' data. The data loss and leakage, depending on the confidentiality of that information, this could be severe. Cloud service infrastructure can be attacked and is very much a target by attackers. And then just organizations not knowing their risk profile, and maybe they shouldn't have put that file in a certain place, or it was marked confidential, but they shared it on a public cloud platform. So those are kind of their top 7 that they came up with, and that was a bunch of years ago. More current, in February 2013, the CSA published their Notorious 9, as they called it. They increased it to 9. So they added data breaches and data loss. They split those out. And denial of service was added. So a few different changes, but you can see how cloud security and what people thought of cloud security has changed over time. And now recently, just this year, Cloud Security Alliance published their newest top 12 cloud computing threats, what they call the treacherous 12. I like to refer to them as the dirty dozen. Threat number 1, data breaches. So exposure, data gets accessed that it shouldn't by either an attacker or some kind of a compromise, inadvertent or advertent or malicious. Credentials or broken authentication. Maybe we have one of our cloud administrators gets their username and password lost, and now an attacker can take over our cloud infrastructure. Or we're using an application program interface, an API, to configure our cloud service, and there's something in the way we're using a shared password that gets hacked, and then that gives the attacker access to our cloud platform. Could be exploited systems vulnerabilities, something related to the cloud service provider. Maybe there was a insecure version of software that was running that gave the attackers access. There could be account hijacking, again, malicious insiders either on the part of the cloud customer or the cloud service provider. Also, advanced persistent threat parasite. Maybe there was something inside of an operating system image that gave an attacker a foothold in the cloud infrastructure. Permanent data loss, inadequate due diligence and protection, cloud service abuses, denial of service attacks, so shutting down a cloud service, shared technology, shared dangers, so an issue or a vulnerability that would affect multiple customers all at the same time. So this was the CSA's kind of treacherous 12 as they described it. So we can look at these and see, okay, these are the things we have to think about as we start to operate in a cloud infrastructure securely. The Uptime Institute also has their tier standard topology, where it's a model with which they've designed and decided how high availability data centers should be architected from a physical layer. The Uptime Institute creates these standards around service availability, recognizes that that's a critical component of any cloud service. CSPs operate in these data centers, and the data centers need to be highly available. So the tiered system of certification assesses the availability and the physical infrastructure in that data center, promotes increased availability. So there's a tier 1, which is just the very lowest level, basic site infrastructure. Tier 2, redundant site infrastructure, gives you some components might be redundant, but others may not. The Tier 3, which many data centers are concurrently maintainable. So you can have multiple systems, but there may be some systems that if they get worked on, like a power control system or something like that, may take down part of the availability, or may take down the A side, but not the B side. So it may or may not be service affecting for a customer. And then Tier 4, the highest level, is completely fault tolerant. The site can be maintained. Systems can be taken offline. There's always multiple systems, and it never disrupts any service. And so these service providers have 6 nines of availability, extremely high uptime. So if you're using a cloud service provider and they're using data center infrastructure that is Tier 4 data center, you can rely upon that service. We're going to go through examples of cloud services and look at how they're secured and what are our responsibilities and what does the cloud service provider offer us in order to operate in their environment securely. So Amazon Web Services, or AWS, is really a market leader in infrastructure as a service. So remember our models from before. This is infrastructure as a service. So with this type of model, we bear a lot of responsibility in terms of configuration of our systems, our computers, our instances, our virtual machines, the data that's stored. So they are an infrastructure as a service, and they're a public cloud service. So if we make a mistake, our data could be exposed to the public internet. And so stakes are kind of high in Amazon Web Services, and we want to make sure that it's secure if we're using AWS. But they are a market leader, so it bears us looking at them as part of this session. AWS has a super scalable, high availability global infrastructure that's broken across multiple regions with multiple availability zones. So regions are these geographical regions with 2 or more availability zones. Each availability zone really a separate data center. And so there are multiple data centers in a region, and they call them a region, and certain types of reliability can be provided within that region. And we may choose a region to operate in AWS because we want our data or our service or our application to run geographically close to maybe where the users may be accessing it. Availability zones are physically separate, many miles apart data centers that are redundant, and it requires multiple data centers in a geographical area there to be called an availability zone. And then we can look at the AWS Service Health Dashboard website to give us an indication as to how these are operating and whether they're green or red. But if we can definitely build a very high available application across AWS infrastructure if we build it correct and we're using multiple availability zones and multiple regions and so forth. And there's certain applications and components of AWS that allow us to do that. AWS possesses almost all the major security certifications and attestations. They're a FedRAMP, a FIPS, ITAR, FISMA, NIST requirements, certified cloud service provider, and many others. They have just about every certification. And AWS recognizes that because their public cloud infrastructure as a service, they need to be very secure, and insecurities on their part would lead to breaches that would be public knowledge and would affect future customers using their services. So AWS definitely recognizes the importance of security. It's something they take very seriously, and they want to make sure is preserved so that they can continue to be the market leader in this space. So AWS has this shared security model that defines the responsibilities for themselves as well as the customer. And so the shared security model helps customers recognize what they need to do and what AWS is going to do for them to help make the infrastructure secure. AWS takes care of a lot of the global infrastructure that we talked about, and making sure that that is high available. AWS also performs the foundational services, the computers, the storage, database, and networking. AWS takes care of the security of the cloud, and the customer is really required to define their controls of operating in the cloud. So the infrastructure being the network, the configurations, data, and access, and then the applications that the customer runs are the responsibility of the customer. So everything above that orange box at the bottom is the customer's responsibility. And this also changes depending on what types of services you may be consuming from AWS. If you're just consuming infrastructure as a service services, then this shared responsibility model for infrastructure services is used. If you're using a container service like RDS, the database service, then AWS provides the platform and application management. AWS manages the operating system and the network configuration for that container service. So AWS is taking on a little bit more responsibility for a container service. And then if you have an abstracted service like DynamoDB or Lambda or something like that, then AWS provides even more of the responsibility, plus server-side encryption for the platform, network traffic protection for the platform. So the platform that you're using, then AWS takes a little bit more responsibility for some of those abstracted services. So it depends on which type of service you're consuming, whether it's infrastructure, container, or abstracted. If you're using infrastructure services, then you as the customer bear the most responsibility. And if you're using something like S3 or EC2, Simple Storage Service or Elastic Compute Service, then you bear more responsibility with an infrastructure service. So it also depends on which of AWS's services you're consuming may change how you're having to secure that infrastructure or that particular application type. AWS provides some valuable security white papers, and much of this is on their website. Because AWS may or may not have a help desk that you can call, they really try and put a lot of effort into documenting their security information on their website. So if you go to aws.amazon.com/security, there's a lot of their documentation out there that can give you guidance. There's an introduction to AWS security, which is a simple paper that gives you kind of the high-level view of the shared security model. There's an overview of security processes. This is a little bit more detailed document about how they operate. AWS security best practices. This is a great document, spells out many of the details about security, your responsibility, how the different security components and characteristics are provided by AWS or by you, and gives you pointers to other documents to look for, other guidelines. And if risk and compliance is something you're interested in, they have a white paper for that as well. So AWS really tries to provide a lot of this information on their website, so it relieves them from having to, help all their customers. They document a lot of this information on their website. And then each particular AWS service has its own page, its own best practices, its own security guides. So these are all on their website, available to look at and download and use for free. One of the key things when operating in AWS is the identity and access management practices used. So IAM is really this practice of defining who of your IT administrators have access to control which types of functions and make which kind of configuration settings in the infrastructure that you're consuming. So you define users, groups, permissions, and these keys and these access keys for API calls, and you want to restrict those so that you're giving administrators only the level of access they need to configure the resources they need and no more, which kind of contains the blast radius. If one user gets their credentials compromised, then it limits what that attacker could do. So you really want to lock down this master account, this root account, and tie it with two-factor authentication and lock that down and only use that when you're doing major account changes or configuration settings, and then have really developer accounts, administrator accounts, only have the specific privileges that they need. So this is really a best practices that Amazon hits on quite frequently in their trainings. It's really about identity, which access you give which person, and you can lock them down so that only particular administrators can have read access to S3 resources. And you can create these access keys and these accounts. You can tie them to EC2 images so that EC2 compute image only has access to do certain types of functions. You could tie it down to particular APIs. You can rotate keys, and so it's helping you be secure. And there's best practices around using IAM. AWS offers multi-factor authentication and recommends that for the master account, so you can tie that to multi-factor, either a text page or another kind of factor that's used to authenticate that user. So AWS also offers a secure token service, STS. There's a web service that grants temporary requests for IAM users. So it gives them only very short-term limited privileges to do specific tasks, and then it times that out. The MFA gives you a text with a 6-digit single-use code that's based on the time-based one-time password algorithm, TOTP, RFC 6238, that defines how these one-time passwords are used. So a very secure method. And so if you have a username or password that get compromised, but with multi-factor authentication, it wouldn't compromise the whole account. So just another level. So even if a computer got infected with malware that had a keylogger, because it's using multi-factor authentication, the keylogger would only capture the one-time single-use code and wouldn't compromise the entire password. So every time, so even if a computer was infected and someone was observing what the administrator was typing, it wouldn't be compromised. Federated Identity and Access Management Console and APIs allow you to extend your Microsoft Active Directory domain. If that's your source of record for usernames and passwords and privileges and groups and accounts, that can be extended with Secure Access Markup Language, SAML, OpenID, and others. You can extend the federation of identity, from your infrastructure into AWS. So knowing who has access to what in your infrastructure is really important, and that's done with IAM groups and roles. In AWS, you're only as secure as your Amazon Machine Image, your AMI. That's the instance file that defines the operation of the operating system. It is possible to build your own images and then save them and reuse them and launch other services off of those images. You can build your own off of a default Amazon Machine Image, or you can import your own if you have a particular security technical implementation guide, a STIG For the requirements that you have to harden your operating systems, you could do that in this way. But when you're storing images, you want to be careful that you don't store the security keys within the image, because then if you share that image in a community, then your keys can be disclosed inadvertently. The AWS Marketplace also offers hardened images. You can buy these from other companies, preset, pre-hardened operating system images for a wide variety of operating systems, and they've already been locked down per certain security standards. So Buddha Labs offers these hardened images that are based on a DISA STIG. So if you're a federal organization, you could look at using theirs possibly. Something you can just purchase off the AWS Marketplace for a fee. In Amazon Web Services, there's this concept called the virtual private cloud. It's really your connectivity, your private connectivity, and the way you do secure zoning and network segmentation in your cloud. And there are best practices around how you configure your VPC, and this defines the connectivity that you would have to AWS. You want to be careful how you document and use internet gateways, virtual private gateways, customer gateways, and connect up to AWS, how you connect this VPC to the internet, and your systems are going to be running in this VPC environment. So this is like your routed infrastructure that deals with IP addresses, private public IP addresses, network address translation. The design of your VPC is really important to the security of how you operate in an AWS infrastructure. You want to be sure you put different systems into different security groups, load balancers, web servers, databases, and different tiers of your traditional three-tiered architecture should be in different security groups, so they have only the permissions that they need to operate. And security groups are much like stateful firewalls and have whitelist behavior. They only permit what you tell it, and everything else is denied. So you want to create these security groups with the minimum number of applications or TCP UDP port numbers required for the application to function, as required. So you can think of them as a fully stateful firewall. And you may not have the flexibility today in your on-premise infrastructure to build a stateful firewall in front of each EC2 instance, but in AWS you can really control this with security groups and maybe in the end have a more secure environment than you have today in your traditional on-premise data center, where you're really relying on the security of your perimeter. And the fact that many organizations have seen erosion of the security perimeter weaken their security defenses. In AWS, it's like having a perimeter at every layer in the three-tiered architecture. So this may actually allow you to operate more securely in a cloud environment. Network access control lists are stateless. They're non-stateful, they're directional, they work like an access control list, much like on a traditional network equipment router. They can also complement what you're doing with security groups. And there are web application firewalls available in AWS also to protect web applications that may be vulnerable to cross-site scripting, buffer overflow, SQL injection type attacks. So AWS and how you connect your AWS resources to the internet is important to document and understand and secure, but then also the ability to use security groups, network access control lists, give you the ability to create enforcement points for your security policy in AWS infrastructure. AWS also offers certificate management to manage your TLS or SSL certificates. And TLS should be used for all of these services. So you want to make sure you're encrypting your data in the cloud and using encryption for data in transit as well. Encryption services are provided by AWS, but you can use them, but really depends on the security of the key that's important. And so to operate them, you have to secure the key. Amazon Web Services offers a hardware security module, an HSM, which is a hardware-based method to encrypt and store the private keys. And it's done with a hardware system in their infrastructure that locks these down, that's tamper-proof, that can't be attacked. And so there's a cloud HSM that AWS offers that can help you secure your keys. AWS also offers services to assist with backups. It's very easy to do backups and snapshots of your images. Glacier is AWS's long-term storage that you can archive and vault data into and store it there for long-term use. It's a little slower and more expensive to retrieve the data from it, but that's the long-term storage. If you want to put stuff there, logs, historical information, create backups, and put them on ice, if you will, for long-term storage, Glacier may be something you could use. It's a very low-cost storage platform, and it's secured as well in AWS infrastructure. If you desire faster rotation, if something goes wrong, then you might be able to use bucket policies or Elastic File System, EFS. You can store things and files in S3, which is their file-based simple storage service as well. And you can create policies and bucket policies to control who can access that data. So you've got a lot of policy configurations. You can tie those to IAM roles. You can tie them to security groups. You can lock those down, and you can create different snapshots and do incremental backups. Everything that you do today, but might even be easier in an AWS infrastructure. AWS offers systems to help you manage your security. AWS has a Amazon Inspector platform that allows you to look at your infrastructure and see what are you doing compared to the industry best practices or AWS's best practices, and give you some prioritized tips for improvement. So an automated system that'll look through all of your configurations. It'll give you ideas on, oh, this security group's a little weak, this could be improved, you're using your root credentials over here, and give you advice on how to lock that down. AWS offers config rules as a way to help you monitor your inventory, perform change management, and it's recorded in AWS config, all of those changes, so you can go back and you have some audit trail to see what was done. If there was a mistake made or there was an attack that was performed, you could gain visibility into it, or maybe there's a malicious insider. AWS config rules may give you visibility into what's happening there. An AWS Trusted Advisor is a service. If you're a business or enterprise support customer, you can get access to Trusted Advisor that'll review your settings and give you areas for improvement as well. So AWS recognizes the importance of security to their customers and wants to give you these automated tools to help you self-assess how you're using AWS services securely and give you recommendations or opportunities for improvement. But really, AWS, because it's a shared security model, it's infrastructure as a service, it's public, and it's a shared security model, it really requires ever vigilance. So you need to really be paying attention to what's happening in your infrastructure. It has a cost implication to you on a month-to-month basis, and so you want to be attentive to what's happening. And a simple mistake in a security setting can really cause a large exposure for your organization. So you need to be very careful with all of these settings. And you can see that because it's infrastructure as a service, it's public cloud infrastructure, it's a shared security model, the customer bears a lot of responsibility. So there's a lot of settings to keep track of. AWS offers CloudWatch, which gives you visibility and polling into your metrics, logs, alarms. Standard is a 5-minute polling interval, but you can get detailed 1-minute polling on statistics and metrics of your environment. There's an added cost to having the increased resolution and granularity of the metrics, but can give you visibility and maybe early warning that something's happening. CloudTrail is an AWS service that provides all the detailed logging, auditing of exactly everything that took place in your AWS environment. It records the API events, API calls, changes, tracking, everything, and gives you all of this data for security forensic purposes, but also operation forensic as well. So you can detect abuse, other kinds of problems, detect attacks, detect insider threats, detect other kinds of things that may not be configured properly through AWS CloudTrail. So a lot of data. And there are other systems that interact with AWS CloudTrail that you can use as well. You can report abuse, report vulnerabilities to AWS, and they'll take your suggestions and with their engineering team continue to evolve and improve the security of AWS infrastructure, their responsibility portion of that. Also, if you want to perform a vulnerability scan or a port scan of your infrastructure in AWS, you must first get permission to do so. So there's also a means to do that through their website. But AWS will provide the distributed denial of service, man in the middle, IP spoofing, port scanning, packet sniffing. They'll provide those features for you. You don't need to do those things yourselves, but you could request these things be performed on your behalf. So, like we've seen before, AWS, a lot of security, the options that they provide, but much of that is the responsibility of the customer to have it set up correctly. AWS has this security ecosystem. They work with many partners. They're the major market leader, so they have the largest ecosystem and set of vendors that complement and extend what they do. And I mentioned the AWS Marketplace, a place where you can consume other cloud services that can complement what you're doing with AWS's native settings. So now, after looking at AWS, now let's consider Microsoft Azure Cloud Services. Azure, also a leading cloud computing service provider. They provide platform and infrastructure as a service services. So depending on the nature of what you're consuming, you may have a more platform as a service type security model here. Microsoft Azure has a full set of compliance certifications, much like AWS. They're also FedRAMP certified. So if you want to operate in Azure services, when you're signing up, you want to make sure that you're operating in their FedRAMP version of their cloud, or the instance of their cloud that is secured for federal workloads. Microsoft follows their own secure development lifecycle and operational security assurance, OSA processes. So the software that they're developing for Microsoft Azure are the same processes they use when they develop any type of software. So Microsoft, much like AWS, very secure coding practices on their behalf to make sure that they anticipate what attackers could do, lock down the code ahead of time to minimize attacks as best they can. Microsoft offers AD authentication and integration, two-factor authentication, encryption, DDoS prevention. They offer a key vault that's also a FIPS certified hardware security module, HSM. There's a Microsoft Azure Trust Center that gives you visibility into how you're operating. It gives you a dashboard for understanding your security settings and everything like that. And Microsoft offers Azure Security Center, gives you this visibility in this dashboard, and it's integrated in with Microsoft Global Threat Intelligence, so they understand the current threats on the internet and who's attacking who moment by moment, and that intelligence about current attacks on the internet is fed automatically into their system, and you benefit from that up to the moment security research that they're performing to help you defend your applications running in Azure Cloud Services. So Azure, much the same way as AWS, infrastructure as a service, it's a shared security model. You need to secure your applications you're running there. You need to secure your data, but Azure can provide a little bit more if it's a platform as a service type service you're consuming from them. Another complement, you can see the differences in the styles. Google Cloud Platform Security is infrastructure as a service cloud service provider. They leverage their own infrastructure that Google uses for search and YouTube and their other applications they make publicly available. And they offer that for rent. That pool of resources can be rented and measured service as a cloud service. Like other infrastructure as a service platforms, it's a shared security model. The customer bears responsibility to secure how they're using those cloud services, and Google provides you tools and capabilities to secure that. Google has many of the common accreditations, PCI, SOC, but they don't have FedRAMP accreditation. To my knowledge, it's probably in process. They're ISO certified. They have the FISMA moderate compliance. So you see it's a little different. And Google doesn't have quite as much documentation out there available to their customers as AWS. So you, in a shared security model, bear even more responsibility to go and figure out how you're going to operate securely in a Google platform security. And this is true even more so with DigitalOcean. DigitalOcean is really popular development environment for DevOps organizations. developing web applications. It's a public cloud infrastructure where on your own, you can make your own web applications secure. It's really up to you to make sure your web applications are secure. They publish some privacy policies. They have some very basic cloud security information on their website, but not much documentation. And you bear a lot of responsibility here and when using their services. So it's even more so up to your application developers, your DevOps teams to consume their resources securely. It's infrastructure, you're building web applications, but you're left to your own resources to make sure that it's secure. You don't get very much assistance. So compare and contrast that with AWS or Microsoft Azure. With Salesforce.com, they're a cloud CRM SaaS provider. That's how they kind of started out. They offer other cloud services as well. But because it's a software as a service provider, as an example, much of the responsibility for securing the infrastructure falls on Salesforce.com. You as the customer are really just eating the pizza at the pizza restaurant, so it's up to Salesforce.com to secure all of the infrastructure, the application, the compute, the storage, the network virtualization, and the multi-tenancy. You're just more interested in consuming that application and the storage of your data in the cloud. Salesforce.com has a mature set of security practices throughout their whole company. Security is very much woven into everything their development teams do. But you do have to understand your responsibilities. You're responsible for user authentication, so who's getting access to those software as a service services. And you can do that with SAML, OAuth, roles, permissions. You have to grant who has access to what. Administrator accesses, user accesses, you define those. You're also responsible for your data security and who you share that with, and any other third-party tools that tie into that Salesforce data set are also your responsibility. Programmatic security, if you're writing certain type of SOAP APIs, metadata APIs, if you're writing your own code, the security of your code is your responsibility. And Force.com, there's a security code scanner that can look through your code and give you critiques and help you write secure code. So Salesforce.com, a SaaS provider, you can see the differences in the shared responsibility model here compared to infrastructure as a service as like AWS. You can see that Salesforce bears more responsibility here. You don't have to worry about nearly as much with a SaaS provider platform when it comes to security. When it comes to cloud storage, we mentioned earlier that there were many breaches in terms of cloud storage solutions that led to, data leakage, and these have been documented and popularized in the news and the media. If our organization is going to use a cloud storage platform, we want to make sure that we're using that securely as well. And there are some common methods to securing data in the cloud. We want to make sure we're using multi-factor authentication, that we're tying that to a token, a one-time password, or something biometric. And if we're doing single sign-on or federated identity management, that we do that in a secure way. We want to make sure we have audit trails. We know who's accessing which files and folders, and audit trails just from revision control and versioning of files that we may be storing in a cloud storage environment. Reporting, logging on those files that are stored and who accesses them is important if we do have a security incident to go back and investigate. There's role-based access controls oftenly provided by these cloud storage providers, and access policies. We can define who has access to which files. We also have the ability to create policies around what types of data, and if we have secure watermarking, if we watermark and mark certain files based on their classification of confidentiality, if we have a high-quality cloud storage provider, they can monitor those watermarkings and make sure that documents that are marked company confidential are only accessed by corporate executives and not by the general public. So they can also watch, based on data classification and marking, who's using what types of data, and identify and alert you to the fact that there may be a confidential document that's shared in a public way on their infrastructure to help you know that sooner and go and remove that file or clean up any kind of data exposure that might have occurred as part of that. You can encrypt the data, and if you encrypt the data, you want to make sure that you as the customer are retaining control of the key. You want to make sure there's data integrity, that those content security policies are being enforced, and you may encrypt the file prior to sending it to the cloud storage provider. So if you encrypt the file with your keys, you store that file on that cloud storage provider's infrastructure. If that file is leaked inadvertently, the file is already encrypted, so there's no exposure. A new concept in cloud storage security is this concept of data dispersion. Use 3 or 4 different cloud storage security providers and store a portion of files across all 4 providers. So if any one of those cloud storage providers has a compromise, they don't get the whole data set, or they only get a portion of a file that's not really usable. So data dispersion is another technique for spreading out your risk. And there are starting to be systems and services you can consume that do data dispersion. But if you're going to use a cloud storage provider, you want to make sure that it's certified, that it operates in secured locations, in data centers that are tier 3, tier 4 data centers, where they have redundant systems, they're constantly monitoring. And then when that service provider has a failed hard drive, you want to make sure they're following media destruction guidelines and destroying that hard drive per your requirements. Just as if you were to have a failed hard drive, if it contained confidential data, you would want to make sure it got destroyed in a proper manner. You'd want to make sure those cloud storage providers are following those same best practices. So now that we've talked about, cloud security, the different models, some of the concepts, now we're going to talk about, and we've seen some examples of cloud service providers and how we have a shared security model operating in those environments. Now let's talk about how software containers change how we think about security. So a software container is this concept of breaking up an application into smaller parts and putting each one of those parts into a container. In the past, when we've had a virtual machine, we basically run an operating system on that virtual machine, and then we run an application onto that virtual machine. And so we have to treat that virtual machine as a combination of an operating system and the applications that run on top of that operating system. And it's really like a virtual computer. With a software container, what we've done is we've abstracted just the application, and the application runs and is decomposed and runs on a stateless set of underlying infrastructure. So it's like there's one operating system running, and there's many containers of just the application running on top of that in a stateless way. So the benefit here is that we can turn up another container instance of an application without having to turn up another whole complete operating system. So if we were to start up another virtual machine or an EC2 instance in AWS, it takes time to start up that process. It takes time to boot the operating system, takes time to start up everything, the file system, and then launch the application. With a software container, the operating system is already running. It takes just an instant to launch the application. So let's say we want one Apache web server, and now we want 2 Apache web servers. We just run the software container, boom, run another instance of that application. Instead of having to boot up a laptop and run Microsoft Word, we just start another instance of Word on an operating system that's already running. This ability to decompose applications into their essential little components, run many different little pieces of applications, and spin them up fast and tear them down quickly, lends themselves to cloud computing, because we can gain that elasticity and massive rapid scalability in turning up or turning down our services as we need, and we only are using the compute resources that are required. So many organizations that are operating in the cloud are looking to software containers as a way to create their applications in such a way that they get rapid elasticity and scalability and automation as part of this, and also reduce their costs and reduce their operating system licensing cost. Software containers really started with this in the Linux environment with this concept of Linux containers, LXC. This method of virtualizing applications and C groups to isolate these different applications in terms of how much memory, CPU, and file access they get and their network resources. And so it isolates the application from the operating system and everything like that, and it containerizes it, and there are some, security benefits here. So here we have a picture that kind of describes this concept. We have a base Docker host. Docker is a very popular architecture and system for using software containers, and it's a popular open source method to manage the containers, spin them up, change them, create images, and so forth. And so we have a Docker daemon that runs on the Docker host. We can execute commands like docker build, docker pull, docker run to create and run additional containers. And based on the data store, these containers can get spun up or spun down, and we can build our applications in this way. And we have elasticity and scalability. And so this is just an example of how software containers are used, and they can be isolated from each other. They can be isolated and controlled in terms of the access and the data they handle. And so Docker and software container security is important. If we know we're operating in a cloud infrastructure and we're using containers, we want to make sure we consider the security of the containers as well. Containers, all those software containers running on that Docker host share the same kernel. So we need to make sure that that host kernel is hardened and not vulnerable. If the host kernel is not hardened in any way and is vulnerable, then the containers above it running on it will also be vulnerable. Containers can start with their default policy, but you can control that and restrict that. But it is possible to have one container affect another container if it's not restricted. It's also preferable to run each of these processes in a non-privileged account, and each user should run in a separate Docker host. So if you have a certain type of application, you would want multiple Docker hosts and then use each Docker host for a separate type of user. You can validate the security of your Docker images, consider using a scaled down Alpine Linux to create minimal images and harden the operating system that Docker runs on top of. You can also limit inter-process communication and set limits on CPU, memory, and file system access per container. You can limit security exposures for containers with seccomp and do other things to harden your kernel, for example, like GR security, PAX, or twist lock. So this gives you more things to consider if you're using containers to secure them, but they can give you some benefits for rapid elasticity and scalability of your applications in a cloud infrastructure, but there's a few more settings you need to check, particularly the security of the host kernel when operating in a cloud infrastructure. Now let's think about some of these other emerging. There's some vendors here that have some interesting components that may change the way we think about how we operate in a cloud environment. We'll talk about Splunk, Dome9, TrendMicro, and Bracket. Splunk is a software application for searching, monitoring, analyzing machine-generated data. It provides data visualization platform for IT operations operating in a cloud environment or physical environment. And it often gets introduced to an organization through the security use case. Splunk can be used with AWS to gain additional visibility to how that's operating. It can be integrated into Google's cloud platform as well. So you may be using Splunk on-premise as a central logging system for all these IT systems to log data to. Splunk can be used for an Internet of Things, data visualization. It can take all of this unstructured machine-generated data and make sense of it, graph it, chart it, so you can understand and gain business intelligence and perform analysis on the IT log data and what's happening in the infrastructure. You can track operational events and alert and create reports on all of this data. And you can manage and monitor your cloud infrastructure using it as well. Splunk uses a bring your own license, BYOL model in AWS Marketplace. And you can use Splunk Enterprise, Splunk Cloud, Splunk Lite, or Hunk, which is Splunk on Hadoop, and use this to monitor and manage your cloud infrastructure. So another way to get visibility into how your cloud may be being used securely or insecurely. Dome 9 is a new and innovative SecOps, security operations, cloud security visualization platform that works with AWS. It provides policy controls for EC2 and VPC security groups. It gives you change control, configuration management, so a bit of more than what you might be able to achieve with CloudTrail, Config, other tools that AWS provides. It can detect tampering, abuse, stop unauthorized, non-permitted configuration changes, so it can provide you some policies and watch your AWS infrastructure and then intervene. It can also provide firewall policy management, firewall integrity monitoring, a variety of other functions to give you, the compliance that you need. It provides a centralized security management. It provides tamper protection. It can revert mistakes that are made. It can stop unauthorized configuration changes. It can lock into a particular AWS region. So if you say, I only want certain types of functions to run in US East or US West region, it can prevent an administrator from running a workload in a European region, for example. It can do configuration management, dynamic access leases, file integrity monitoring. It can do other kinds of compliance auditing. So an auxiliary tool that can be added to AWS, EC2, and VPC configurations. And here's kind of a picture of what that dashboard looks like. Gives you a view of kind of external DMZ, view of your infrastructure, understanding and documentation of your VPC topology here, and then events that are taking place and which applications are being used in which area. So this Clarity console may give you some other added visibility that you may not have traditionally in AWS. So something to consider. Trend Micro also has their antivirus software, their deep security integration with AWS. This can defend against network-based attacks, provide IPS, virtual patching, and keep malware off of your servers that you may be operating. It works with AWS. It can identify malware and help you protect your servers that may be running in AWS. It can uncover suspicious changes, give you alerts, kind of help you speed up PCI compliance if you're using this on your servers in AWS. And it can be consumed through the AWS marketplace. So something that AWS doesn't provide, but something you could use on an AWS system to add to the security of the images that you're running in EC2. Bracket is an example of security protection for cloud infrastructure that's a proxy-based encryption system. It basically is a hypervisor that encrypts the machine images that run on top of it. It provides this metavisor, as you see here in this picture. And the applications and operating systems and virtual machines that run on top of Bracket are secured by this metavisor. There's secure storage, secure data in transit that the metavisor provides. So any data that that application or that container runs on that's running on top of Bracket writes to the physical infrastructure will automatically be encrypted. So to the end user using the application, they don't see any encryption taking place. It's being taken care of in this lower abstraction layer. So even your developers who are working on that guest operating system, they don't notice any difference, but you can enforce policies. You have a management platform that you create these policies. The metavisor is at the very low foundational hypervisor layer, and you have this ability to create these policies for encryption of data at rest, data in transit, data in use, and it can run across multiple cloud providers. And so this is kind of an example of how you're using encryption to secure all of this, but make it completely transparent to the end user that these security policies and encryption are being performed on behalf. of you operating in this cloud infrastructure. And it's something the infrastructure and the IT teams can control, but the application users and developers don't even know that this is taking place. So a way to retain control and security operating in a cloud and make sure everything is encrypted. So an example of something new and innovative that the cloud is allowing us to do with security. So now let's talk about, how security services can be consumed from the cloud. In the past, organizations have performed all of their security themselves for their internal IT infrastructure, but maybe the cloud changes the way that enterprises can receive benefits from the cloud. There are cloud application security brokers, CASB. These are systems that pay attention to which cloud services your end users may be accessing. Cloud application security brokers can reveal shadow IT, can reveal users who may be using cloud storage platforms that don't follow corporate security policies or are misusing cloud services in some way, or using ones that are non-approved, or end users who are violating data classification violations, storing data that's classified and marked confidential in ways that they shouldn't on like a public cloud service. Cloud application security brokers can operate either inline at the security perimeter, watching traffic that's going back and forth as either a physical or a virtual appliance. They can operate as a web proxy, doing HTTP and HTTPS inspection of cloud-based services and accesses following using a web browser, or they can be DNS-based, where they redirect connections through a cloud-based service. They can enforce the policies and identify, when end users are accessing certain types of services. They can check for credentials. You can build policies based on encryption, location, the device that the end user may be using. They may run as an agent. They may do profiling of the user traffic, logging and alerting to security violations that may be taking place. And there's a large list here in alphabetical order of cloud application security brokers, or cloud access security brokers, as they're sometimes also called. So this may be something that an organization may use to try and get a handle on shadow IT and unauthorized cloud use, but then also gain visibility and assurances that the cloud is being used properly by their end users. There are also other ways that companies can use cloud-based services to add to their security. Many organizations, leverage capabilities of the cloud to reduce the technical debt of security management. For example, every time an organization buys a security platform and uses it in their internet perimeter, now there is the technical debt to manage that device, to pay for software licensing and maintenance, to keep it updated and patched, configure it, control it, log it, monitor it. There's all that technical debt that goes along with buying a security service or platform. So organizations that have mobile workforces then cannot direct the traffic through those traditional perimeter internet security defenses. Maybe not all their IT workers are within the enterprises and aren't accessing the internet through that choke point at the internet perimeter. Therefore, they've got a diverse workforce and they want to be able to provide security measures to those end users. So some security vendors offer subscription-based security solutions that get threat intelligence data feed that can be consumed not just by end users at the corporate data center or headquarters location, but also remote branches and remote employees. So for example, content filtering. So an organization might have a content filter at their perimeter that prevents users from going to, websites that might waste time and not be in line with corporate policies. But when a user is at a coffee shop or working from their house, their web traffic may not be directed through that system, but yet they're still using a company-owned or department or agency-owned compute asset that they've been granted a laptop to take with them. So the cloud-based content filtering system may be able to protect that laptop from going to malware-infected sites even when it's remote. It'll do the checking in the web. Those web requests will be directed to a cloud web content filtering system before the end user can go to that website, and thus protect the laptop even when it's outside of the corporate walls. Other solutions might be, periodic vulnerability scanning. So a cloud service might be able to scan your organization from the internet perspective, do web security assessments, give you reports. There can be options to use distributed denial of service mitigation techniques in the cloud to prevent you from having to buy a component to run on your internet perimeter or in your cloud services to defend them. You can also have managed security service provider services used over the cloud. You can send your log data to a security information event management system in the cloud operated by an MSSP in their security operations center in their SOC, and that prevents you from having to maintain that service, operate that, staff it 24/7, and then that MSSP will be watching all of your data using their algorithms, using their security information event management system to alert you to security incidents that may be occurring in your environment. So another way where you could leverage the power of cloud services to help your organization be more secure. So now that we've covered cloud fundamentals, cloud concepts, cloud security concepts, we've given examples of different cloud service providers and how we bear responsibility for securing using them. We've talked about some of the added functionality. Now let's talk about cloud security certifications that we could obtain and how we might continue our learning on this topic. We'll talk about the couple of certifications here, and it may be of interest to you to go and learn a little bit more about cloud security. The Cloud Security Alliance has their Certificate of Cloud Security Knowledge, the CCSK. As I mentioned before, Cloud Security Alliance is a vendor-independent organization. They have this vendor-independent certification that focuses on these 14 different domains. It has these guidance. It's based on the guidance in their version 3 of their cloud security guidance document. So everything from architecture, governance and risk, legal, e-discovery, compliance audit, how you manage information, portability and interoperability between cloud providers to avoid vendor lock-in, how you do traditional security, business continuity, disaster recovery, data center operations, incident response. How does cloud change the way you respond to incidents? How you handle applications, deal with keys, identity and access management. We've talked about many of these topics already today, but these are the topics that this certification focuses on. The Cloud Security Alliance also provides the Cloud Controls Matrix. The CCM is a gigantic spreadsheet that lists over 130 different control specifications across 15 different control domains. It's a free Excel spreadsheet that you can download from their website that gives you all of this view. It does mappings between FedRAMP, low, moderate, ISO, NIST, among many other popular cloud security certifications. It's a valuable resource that can remind you of all the different controls that you have to consider when operating in the cloud, and you can download it from this URL here. But this is something that is valuable. Here's a view of what this table looks like. The text here is far too small to read, but I just wanted to show you that it's organized. It's color-coded on the left-hand side. There's many different controls, and then you can go across and see what's the FedRAMP view of this? What's the ISO view of this control? What are the NIST? And it provides you all these references and mappings of controls to control specifications across all these different domains that the CSA has. So a really valuable resource to go through and say, if I'm interested in data encryption at rest and controlling keys, there'll be a control specification for that, and I can look across and see how that maps to FedRAMP or how that maps to NIST 853, for example. So valuable resource for tracking cloud security. The CCSK, you can take their classes or you can read their free available documentation on the website. their security guidance, the CCM, and so forth. You can read some other documents like the European Network for Information Security Agency has a white paper on cloud security. There's Cloud Computing Benefits Risks Recommendations document there. The CCSK also is tied in with other NIST documents that we referenced earlier. There's a preparation guide. It's an open book exam that you can take online. You can use your own computer to take it online over the internet. About 60 questions, about an hour and a half. You have to get an 80% or better score on the exam to pass, but you get 2 attempts at passing. So, in my opinion, not a very difficult certification to get, but covers many of the popular domains. And if you're working on, cloud security, this would be useful. Even if you didn't go and get the certifications, it's valuable just to use their Cloud Security Alliance guidance document, version 3.0, to understand all of the domains that you need to consider when you operate in a cloud environment to make sure that you didn't forget anything in your security strategy. The ISC Squared also has their Certified Cloud Security Professional, their CCSP certification, and they have a body of knowledge that consists of these 6 domains, fewer domains, but covers much of the same information as the CSA. The ISC Squared and the Cloud Security Alliance work together on the CCSP. The CCSP covers a broader set of domain. It has a lot more information to study. It's based on many of the ISO and other documents like the ENISA document and the NIST documents, and pulls all this together as a very professional certification to go and achieve. These are kind of the examples of a little more detail about the 6 domains. Starts off kind of focused on architectural concepts, much like we did today, talking about cloud data security, how you store data and use data in the cloud platform infrastructure security, so understanding the different components in a cloud environment and how to secure them. It covers, cloud application security. What do we have to be aware of when we're developing software or consuming software in a cloud? And then operating in a cloud, what do we need to do to monitor, manage, operate effectively? And then legal and compliance topics as well. So you can take their training in person or online. You can take their on-demand class, and there's a official book, a study guide now that came out. This certification is fairly new. It started to become available in 2015, and now in 2016, more people are starting to achieve this certification. If you're a ISC Squared member, you can get a discount code. There's free flashcards online. But this is a Pearson VUE exam that you have to go to a testing center to take. Somewhat expensive exam. It's many hours of a test. You have to score a 700 or above out of 1,000 on the test to pass. So something to consider, but definitely takes a lot more time to study. The body of knowledge is a lot larger than the CCSK, but still is a valuable certification to try to achieve and gives you guidance on all of the different things you need to be concerned in how to secure a cloud infrastructure and how to assess it. SANS offers a two-day class at many of their conferences. It's an in-person or online self-study class that goes through many of the same types of concepts. But you can see how they've broken up their 2 days of curriculum and what different topics they cover. But you see that there is some overlap. Identity and access management on the second day, intrusion detection, intrusion response. You can see now these common themes that keep coming up with regards to cloud security. In summary, cloud security, kind of the bottom line here is that security has more to do with people and processes than with technology. It comes down to just discipline and being precise about what you're doing and the settings and all those little tiny details in IT that make you secure. I often tell people if you have bad information security hygiene in your on-premise IT infrastructure, it's likely you're going to have poor security when you operate in the cloud. If you're good at security and you have good practices, you have disciplined people, and you follow best practices in your on-premise data center, chances are good that you'll follow those same best practices when you operate in the cloud. Cloud services can certainly be less secure. If you're insecurely operating in a public cloud infrastructure as a service, where you bear responsibility for a lot of the shared security model and you're not following best practices, you're at a high risk of a data breach. You can also operate in cloud services equally secure if you follow the same practices you do today in your infrastructure on-premise, and you follow those same practices for operating in a cloud-based infrastructure. You can be equally as secure. But there are also opportunities where you can be more secure in a cloud environment. Like, for example, how we could use security groups in AWS to really restrict things. We might be using software-based containers and restricting and using IAM policies. We have the option to be even more secure in a cloud infrastructure than we do today in our on-premise. It's a choice we can make, and it's just about being aware of what settings are available, being aware of all the different aspects of the domains of knowledge and the topics we have to be concerned about when we operate securely in the cloud. But if we take all of that into account and we follow those best practices, we can actually operate a more secure infrastructure in the cloud. For example, if we have a high availability application, our ability is increased to provide patching. Maybe because our on-premise infrastructure doesn't allow for high availability, we have to take the systems offline to patch them. If we're operating in a cloud and we have 2 applications running, we can patch one, bring it online, take the other offline, patch it, not disrupt any service, and we actually can operate more securely and apply patches sooner in a high availability cloud infrastructure than maybe we can do today in our on-premise environment. So clouds could be less secure, equally secure, or more secure. It's how we handle that. It's up to us. So it can be easier, in fact, to secure cloud infrastructure right from the beginning. Because as you're doing a new deployment, it's easy to build security into the design, into the architecture right from the beginning, rather than add it on afterwards. We may have many things inside of our on-premise data center infrastructure that's operating insecurely, but we feel safe because it's behind our security perimeter, it's operating in our own private data center, that we have gotten the false sense of security that it's impervious to attack. When we go to launch a new system in the cloud, we consider those security implications up front, and we plan that into the deployment. So maybe we can make sure that it's even more secure right from the start than having to add on security after the fact. But having good design, implementation, and best practices, proper maintenance, and vigilance can make our cloud systems very secure. There are some sample questions that I often get asked about cloud security. One is, what are some of the best ways to protect our data in the cloud? So an easy answer is encryption. Encryption is one of the best ways to protect our data in the cloud. We can use a cloud platform to encrypt our data, but we may not want to store our keys, the component of the encryption that really makes it secure. The algorithm isn't secure, the security is in the key and the confidentiality of that key. We may not want to store the key in the cloud where the encryption is being performed. We may want to retain the key in a separate password safe in a separate location or in a separate service. We can also use techniques like data masking. We can mask out a credit card number, or we can use tokenization, where we store a token value in exchange for the actual data and then later exchange the token for the actual value. We can do data dispersion, as I mentioned before. So when we store data in the cloud, we have an opportunity to store the data even more securely than maybe we do today. Another question might be, what would we do if our cloud service provider was hacked? What would be our response? Well, I think you would follow your same incident response process, your business continuity, your disaster recovery plan that you have today for your infrastructure. You would follow that same incident response plan. You would try to prepare for such an eventuality by doing, encryption and what have you. But when you first identified that there was an incident, you would try and detect it as soon as you could. You try and identify if there was a problem and assess the damage potential. You would try and contain the issue, eradicate the incident, remediate, recovery, and then follow through your normal incident response life cycle by identifying lessons learned, moving into preparation and go back through and reevaluate security for that system. So you'd follow your same incident response policy and process that you do today. Another question I get asked, what aspects of operating in the cloud may actually be better? I think I alluded to this before, like patching I think is better. It's easier to perform in the cloud than you may be able to achieve in your current on-premise data center. You may have greater visibility to what's happening in a cloud infrastructure. You may not have as much monitoring or metrics that you get from monitoring or how you operate your on-premise IT infrastructure. You can definitely recover faster. You might be able to snapshot and recover faster in a cloud than you could in your on-premise data center. Backups, if you back up from the cloud to the cloud, your restoration time may be faster. If you had a physical disaster in your current data center, your ability to restore service in a cloud may be faster as well. So there are a few things that may actually be better in a cloud environment. Also, cloud service providers, because it's such a competitive market space today, the cloud service providers are incented to help you protect your cloud infrastructure. So they are looking out for you as a customer, or they should be, to try and make sure that you're operating in their environment securely, because they don't want to have a breach of a high-profile customer making it seem like their infrastructure isn't secure. And then to go along with that, I would ask the reverse of that. What aspects of operating in the cloud may actually be worse or less secure? I think public access may increase your exposure. As I mentioned before, if you're using a public cloud service, you're just a couple of button clicks away from a data leak. Application teams may rush in to a cloud infrastructure because it's very easy for them to consume and develop, but they may not consider security right from the beginning. And so if you have a DevOps team that is using agile methodology and not considering security in the development lifecycle, you can end up with a less secure environment. So those might be best practices to consider. Some people often ask me, well, if I was interested in getting a cloud security certification, should I get my CCSK before obtaining my CCSP? What order should I take some of these certifications in? And I say definitely yes, regardless of whether you get cloud security certification or not. I think it's important to leverage the resources that are available for free on the web, like that the Cloud Security Alliance makes available. But I think that the CCSK is a good certification to get started with because it's a self-study, open book, online exam. It doesn't seem to take as long to study for. It's a smaller body of knowledge. The CCSP is a larger body of knowledge and would definitely build upon what you already learned when you're taking the CCSK. So that might be my recommendation there. Another question I often get is, how should organizations with siloed IT departments start to plan for security in the cloud? And as organizations, I guess I answer that by thinking about DevOps. As organizations are starting to converge software development and IT operations together into DevOps to gain greater agility and the ability to release software features to the business faster or do continuous integration, continuous deployment faster, those same practices are being used by organizations when they move to the cloud. And so those organizations need to come together and as part of the design. So DevSec, NetOps, or however you create your portmanteau of combining words together to form a new word, are also valuable for the cloud. So you want to create these cross-functional, interdisciplinary teams that are aware of the full IT software stack that you're trying to implement. you'll end up getting, and if you can get security integrated into those teams right from the beginning, I think that'll really help your organization move into a secure cloud infrastructure. But if you try to move into cloud infrastructure with very siloed teams that think it's the other team's responsibility for this and that, you may not have as good a results than if you got your teams to work together and collaborate and be cross-functional as you plan to move to the cloud. We appreciate you attending this session on breaking down cloud security. So with that, we'd like to go ahead and conclude the session.